Double distribution is very similar to single distribution. So recall that in single distribution, you took the first value and you multiplied it, distributed it to the first value to get 2x squared, and then you distributed it to the second to get plus 10x. When you do double distribution, you're going to multiply each left term with each right term. For example, if you were given x plus 2 times x plus 1, this is where we would need to double distribute. So I'm going to take each value on the left. So I'm going to take x and multiply it by both x plus 1, or x and 1. And then I'm going to take 2 and multiply it by both x and 1. Alright, so this is what it looks like. X times x gives you x squared. Then x times 1 gives you 1x. Then 2 times x gives you 2x. And finally, 2 times 1 gives you 2. The only thing you have to do now is you have to combine like terms right here in the middle. So your final answer is going to be x squared plus 3x plus 2. Let's look at another example. Alright, we have x minus 7 times x plus 3. So your first move is going to be multiply x times x and get x squared. Then x times 3 and get 3x. Now it's negative 7 times x, so now we're going to have minus 7x, and then negative 7 times 3, which is going to give me minus 21. Again, we have two terms in the middle, my linear term, that I can now add together to get, or because they're like terms. So my final answer is x squared minus 4x minus 21. Alright, so let's look at another example with our negative or our minus sign in a different place. So let's say we had x minus 5 times x minus 4. First step is going to be to multiply x times x and get x squared. Then x times negative 4 and get minus 4x. Negative 5 times x gives me minus 5x, and then negative 5 times negative 4 gives me positive 20. We're going to add the like terms in the middle, and then our final answer is x squared minus 9x plus 20. Now I want you to try number 1 and number 2 on your own, and then write it down, pause the video, and in a couple seconds I'm going to start explaining them. So then you're going to see if you got the correct answer. Now keep in mind, number 2 looks a little bit different, but you're going to apply the same exact concept every single time. So see and try and see if you get the right answer. Okay, in number 1, the first step is to multiply x times x and get x squared. Then x times negative 1 and get minus x. Negative 3 times x gives me minus 3x. And negative 3 times negative 1 gives me positive 3. Next step is to add the two terms in the middle because they are like terms. And our final answer is x squared minus 4x plus 3. If I asked you to name this, could you? This is a quadratic trinomial. Okay, let's look at number 2. Since we have this 2 right here in front, it looks a little bit different. Again, the process is exactly the same. So you're going to do 2x times x, and you're going to get 2x squared. Then you're going to do 2x times 5 and get plus 10x. And then negative 1 times x gives you minus x. And our last step is negative 1 times 5, which gives me minus 5. I can still add those two middle terms. They're both linear. So my final answer is 2x squared plus 9x minus 5. Again, this is a quadratic trinomial. All right, we have 4 more problems to do. Here are the next 2. We'll have 2 more after this. And these last 4 problems are a little bit different or challenging, however you want to look at it. Again, the process is the exact same, but things look different, like I showed you, or different from the examples I showed you at the beginning. And I made some of them a little bit tougher. So go ahead and pause it now if you want to try these on your own, and I'm about to walk through them. All right, in the first one, it looks different because we have 2 terms. We have 4 and 8 in front of our first 2 terms. But again, same step, 4y times 8y gives me 32y squared. Then it's 4y times 9, which is plus 36y. Negative 7 times 8y, which gives me minus 56y. I'm running out of room. And then negative 7 times 9, which gives me minus 63. All right, so since I'm not on all one line here, here are the terms I can add together. So my final answer is 32y squared minus 20y minus 63. All right, number 4. So this one's different just because our A is on the very right and on the very left. But again, the same process. You're going to do 10A times 4, and you're going to get 40A. 10A times negative 3A, which is negative 30A squared. Negative 1 times 4 gives me minus 4. And then we have negative 1 times negative 3a, which is plus 3a. We still have like terms, except they're not next to each other. They're all the way on the left and all the way on the right. We still need to add them together, and while we do this, we need our final answer in standard form. So I'm going to start with my highest degree. So negative 30a squared plus 43a, because I added my 2 like terms, and then minus 4. All right, 2 more problems. Go ahead, try these 2. I'm about to explain it. Number 5, now we have a quadratic, our y squared in our answer. Same process, same steps, and we've been multiplying and we've been distributing variables and changing our exponents on variables. So remember those rules. 2y squared times y gives me 2y to the third. Then you have 2y squared minus 10 is times minus 10 is minus 20y squared. Negative 1 times y gives me minus y. And then you have negative 1 times negative 10, which is positive 10. Now, this is our final answer. There are no like terms. And if you name this one, it wouldn't be quadratic trinomial like we have been getting. This is a cubic polynomial. All right, let's look at our last example. 2x times x gives me 2x squared. 2x times 6y gives me 12xy. Negative y times x gives me minus yx. And negative y times 6y gives me minus 6y squared. We do have like terms here. 12xy is the same thing as yx. It doesn't matter the order when we multiply things, so we can add them together. So my final answer is 2x squared plus 11xy minus 6y squared. Can you name this one? No, you can't. And the reason why is because there's more than one variable. We can only name polynomials if they're all in one variable. Here we have x and y, two variables. We cannot name it.